Dear friends, architects, consultant engineers, air conditioning engineers, and student of MEP services, welcome once again into VK Jan Sir ki MEP classes. In this particular module, we shall be discussing building energy consumption patterns. Dear friends, let me tell you that India stands third in energy consumption as well as in energy generation in entire global situation. The energy consumption and usage in India in year 2026 says that India is the third largest energy consumer in the world after US and China. Second, electricity generation capacity as on January 2026 was approximately 520 gigawatt. The demand is rising every year due to industrial growth, air conditioning and cooling demand, establishing digital infrastructure, that is data centers, and due to electric mobility in areas like district centers. However, per capita energy consumption in fiscal year 2005 was 18,410 megajoules per person per year, which is very low in global situation, approximately 142nd. Friends, let me tell you, to understand the situation of energy consumption in India uh, as of as of 2026, industrial sector was responsible for consuming 42% approximately of total electric generated. Second is domestic or residential, which stands about 24%. Third one is the agriculture, which stands 17%. And fourth are commercial buildings, which are approximately 8%. And all others like railway and public services consume approximately 9% of energy. Friends, now we are discussing energy generation installed capacity as on January 2026. Coal and lignite, that means conventional energy sources, occupy the major space, approximately 43.8%. Second comes in position is solar, approximately 27%. Now this is commendable. The third is wind energy, which is approximately 10.5%. Then fourth in the series is large hydro generations through river dams and other sources, approximately 9.8%. The next is gas energy, which is approximately 3.9% of total installed capacity. Next is bioenergy, which is of course very low, but stands at nearly 2.2%. And last one is nuclear energy, which approximately 1.7% of total installed capacity as on 26. Friends, quite often we discuss about utilities and independent power producers around the world. They develop, own and operate power plants to generate the electricity to meet the demand from their consumers. An electrical utility is a company in the electric power industry, often a public utility that engages in electricity generation and distribution of electricity for sale, generally in a regulated market. The electrical utility industry is a major provider of energy in most countries. Captive power plants are the plants made by the individual owners for their own purposes as standby purpose. A captive power plant is facility that is dedicated to providing a localized source of power to an energy user. These are typically industrial facilities for large offices. The plants may operate in a grid parallel mode with the ability to export surplus power to local electrical distribution network. Friends, this particular chart is of course taken from ECBC 2016, which has been converted into ECSBC 2024 with almost the same pattern. The major sector-wise use is in hospitality, large hotels, star hotels, small hotels, no star, and in resorts. Second, educational, college or university, primary school or secondary school. In healthcare industry, they include hospital and OPD of healthcare institutions. Commercial shopping complex include shopping malls, standalone retails, open gallery mall, and supermarkets. Business buildings include large offices up to 30,000 square meter of built area, medium office 10,000 to 30,000 square meter, and third is small offices less than 10,000 square meter. Then there is a category like assembly, which includes multiplexes and theater as well. Friends, now we are discussing types of energy used in commercial buildings. Electricity and natural gas are the most common energy sources used in commercial buildings. Most individual commercial buildings have their own heating and cooling systems. However, some commercial buildings are supplied by district energy systems. When many buildings are close together, such as on a college campus or in a big city, it is sometimes more efficient to have a central heating and cooling plant that distributes steam, hot water, or chilled water to all the buildings. This district energy systems may also provide electricity along with the heating and cooling energy. District energy systems generally use fossil fuels, coal, natural gas, or fuel oil, although some use renewable sources of energy like biomass, geothermal, solar, and wind energy. Friends, This is a notional subject, that is life cycle energy in bracket LCE uses in urban buildings. The LCE of a building is sum of four terms. The embodied energy EE insert, which is the energy consumed during the construction of the building, including the energy consumed during manufacturing of material, transportation and construction. The next category is the operational energy insert OE, which is the amount of energy utilized during operation and maintenance of building. Third, the recurring embodied energy, which involves the energy used during any maintenance work. Fourth category is the energy consumed during the demolition of building. The recurring energy and demolishing energy of the building can be ignored. It contributes less than 1% to the life cycle energy of building. Friends, now we are discussing share of residential electrical consumption in India. The overall electricity consumption pattern of India dictates. First is industrial, which is about approximately 41 to 42% of the installed capacity. Second is residential, that is domestic, which is less than 24 to 31% of electric consumption. The third largest is agriculture, which stands about 17 to 22% of total consumption. The last one is commercial, which stands 8 to 10%. Uh, to revise, let me tell you, the residential sector is the second largest consumer of electricity in India after industry. Friends, the Bureau of Energy Efficiency, that is BEE, predicts that India's constructed floor area will increase by around 5 times from 2005 to 2030. As per Dr. Satish Kumar, US AD ECHO 3 project 2011. This parallels other projections such as McKinsey study, which estimates an increase of more than 400 by 2030. These studies predict that India's total residential floor area will be much larger than its total commercial area in 2030. CEU data suggests that by 2050, 80% of the space will be in residential use, while 15% will be used for commercial purposes. Friends, this particular graph indicates the India's moderate efficiency scenario, projected energy consumption of India buildings during 2030 to 2050. Percentage represent the ratio of residential and commercial building. Source GBPL 2012. Friends, now we are discussing residential energy used in India in composite climates. We have learnt elsewhere there are five type of climates in India depending upon the weather existing for 30 years. The average resident energy performance index EPI was as found by Swiss agency, to be in the range of 40 to 50 kilowatt hour per square meter per year. The study indicated that households with more than two air conditioners or more than four occupants have EPI of more than 80 kilowatt hour per square meter per year. EPI tends to be 10 to 15% higher in top floor houses compared to those at lower floors. This is due to exposure of roof and cooling energy required for achieving a comfortable indoor temperature. The study also observed that space air conditioning is the second biggest consumer of electricity and has a significant impact on EPI. With greater numbers of air conditioning units in household, energy consumption is increasingly driven by energy requirement of air conditioning. The EPI per AC lies in the range of 10 to 40 kilowatt per square meter per year, with the stand value being 30 kilowatt hour per square meter per year. The study found that a household with different orientations yield reasonably identical energy performance, indicated that EPI is largely governed by factors of lifestyle and occupancy and not by orientation of unit. Very important. Friends, this particular slide indicates end use comparison of projection scenarios of energy consumption. Uh, it has four components: BAU, moderate, aggressive, or very aggressive in all the four categories throughout year 2012 to 2050. Now, let me define first what is business as usual. BAU refers to normal routine day-to-day operations and functional activities that keep an organization running distinct from project-based work. It includes tasks like customer support, payroll, and maintenance, ensuring stability and consistency. So, at last, thanks for watching my this presentation, and thanks one again from VK Jain, the MEP master.